Morning students, myself Dr. BADI ALEKHYA, Assistant Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today we are going to discuss one of the two important models under natural language processing. One is hidden Markov models and maximum entropy models. Hidden Markov models and maximum entropy models are both probabilistic models used in various fields of natural language processing tasks. When we are considering hidden Markov models, it will be it's one of the probabilistic model, and maximum entropy models will complement the hidden Markov model by providing a principled way to estimate the probability in the given environment. So how Markov properties and transition probabilities will take place in the applications of natural language processing means here in Markov, what is Markov properties means it assumes the future state depends only on the current state and not on the past state. For if you are remembering that in the previous sessions we are discussing that recurrent neural networks, under recurrent neural networks the sequence of words, the next word will be predicted based on the output of the previous word, but in here Markov properties the future states depends only on the current state, it's not depend on the past states. So transition probabilities define the likelihood of moving from one state to the another. Here two important things we have to consider before going to implement hidden Markov models. One is state dependence and second one is transition models. The Markov properties simplifying the model by considering only the present state, it does not considering any past actions or past state information, and transition probabilities will identify that the connections between the present state to the future state by quantifying the likelihood between the states of the environment when we are performing the NLP tasks. So how we are going to inference in the hidden Markov models means first we have to determine the hidden states based on the observed outputs. This is often we call it as the most likely sequence of hidden states. With here we are using three terminologies. First we have need of observation and we need of estimation and we are going to performing decoding. So observation means we observe the sequence of models, that means words in a sentence, how much of frequency the words will occurring in a sentence, and after that we are estimating, figuring that what are the hidden states that created these outputs. We are analyzing that particular things, and after that only we are decoding that in which way we are going to finding the best path to the hidden states using the observation. So what's the understanding here means when we are considering any observation, the sequence of inputs will be helpful to generate some words in a sentence. So some of the hidden words are presented in the hidden states that created these outputs. We have to estimate that outputs and we find the path to identify that particular words to fulfill that particular sentence or output generation when we are performing the NLP task. For example, in Google also we have a dictionary mechanism. If I am typing something, I am going to search for something means the next preceding words based on the current input I am giving, it is going to preceding the next input states and it will be generating and decoding the next words what I am expecting in the search engine. Like that the hidden Markov models based on the probability of the current state, it is going to predicts the future state output. So what is a forward backward algorithm is like our feed forward neural networks. Here also we are going to compute the probabilities between forward and backward pass, backward pass. Like that here also we are calculating forward probability and backward probabilities. How it is based on the observation sequence present for the given model. Here we are using dynamic programming to compute both these forward probability and backward probabilities. So what is forward probability means it is calculating the probability of a reaching to a state at that particular given point of time. Backward pass is nothing but the remaining sequence from not considering at the given time, calculating the probability of observing the remaining sequence from the given state. So at the given state, it will be calculated by using forward pass, and remaining sequence from the given state will be calculated by using backward pass. By combining both these probabilities, we are going to considering the overall probabilities of the Markov models. And coming to the maximum entropy model, here it is one of the statistical model. Here the name itself we have maximize the entropy of the predicted distributions subject to constraints. Based on the constraints, we are going to predict the subject distribution. This approach leads the model that are minimal biased, by preventing the model from minimally biased. How maximum entropy? What is the principle behind maximum entropy is it's giving some constraints. The distribution with highest entropy is the least biased information. Here we are going to consider constraints also. Based on the prior or observed data such as known relationships between the variables, we are going to make a model to perform in a better way. What is model prediction? The maximum entropy model predicts a distribution that satisfies the constraints and maximum entropy. So what is the meaning? If it is having maximum entropy, it is less biased, and based on the constraints, current observed state, if you are going to predict something means it provides better output. So by combining all these two functionalities, the maximum entropy in model will provide best yield results in the given application environment. So what is the principle of maximum entropy means? You make the model is as unbiased as possible based on the given available information. So that's why if it is unbiased means that will provide more robust and generalizable model if we are applying maximum entropy principle. So first is entropy and second one is constraints. By combining these two things, we are going to generate the maximum entropy models. That means first by using entropy we are going to find out the uncertainty in the distribution. After that, based on constraints, we are representing the known information about the distribution. So if you are finding the entropy uncertainty of a distribution, it will be minimize the biased situation in your model, and also it will, when we are providing the constraints based on the known information, will be helpful to find out the unknown information present in the given application. So list here some of the applications for hidden Markov and maximum entropy models. Wide range of applications are there. So like some of the applications we discussed in today's class: speech recognitions, natural language processing, and bioinformatics. In speech recognitions systems to find out the accused properties of speech sound. For example, if at present I am delivering some contents to you guys, how my voice tone, how that whether my sound is in a good presentation or not, and then natural language processing in hidden Markov model and maximum entropy model are used for tasks like part of speech. In recurrent neural networks, we consider that what is the particular word, what is the verb, whether it is verb, noun or adjective, it is going to analyze that information. That's also calculating the probability of occurring the noun, probability of occurring an adjective, the probability of occurring the punctuations, the probability of occurring and adjective functions, proportions, pronouns, like that. It is going to calculate the probability of each and everything, and then it is going to, based on the probability of the things, it is going to map with the post tagging and then performing the mission and then applying mission translations. Based on our input, it is going to react and converting the text into speech. Text into speech we can consider, speech into text we can consider, and then we can consider from language translation also we can perform from one language to another language. So most of these applications will consider hidden Markov and maximum entropy models. In bioinformatics, for tasks like gene finding and protein sequence analysis, because at current state of gene identification will be helpful to analysis The protein sequence will be helpful to analysis the DNA research parts, and also protein sequence analysis in research also it will be helpful when you are applying hidden Markov model and maximum entropy model. That's all students for the today's session. We will meet with some other new concept in the next session. Thank you all.